Hi, I've made some progress on making my wireless cube and wanted to show where things are at now. So I've got my little remote control here with just a button on it and a couple LEDs to show success or failure. And right now the cube is asleep and it's running off a battery pack, and I've got the voltmeter hooked up here so I can see how many milliamps are being drawn from the battery. So right now it's drawing about 21 milliamps, and it's asleep. I haven't, there's a lot of optimizations I'm sure I can do to make it so it can draw less power, but this is just my first go at it. So if I come over here and I click the button here, it'll send a packet over to the little radio that's attached here, and it'll cause an interrupt to happen on the microcontroller, and that wakes it all up, and it starts drawing more power and goes into one of the programs. And if I go and I click the button again, it'll go to the next display that I've got here. And then and you can see the milliamp draw. This is a lot heavier toll on the battery. And I can click it again, and it'll go to a third kind of display. So this is a little bit different color pattern. And then if I click it again, it'll go back to the being asleep. And the other cool part about this is that when it's awake, so I'll just click the button here to wake it up. When it's awake, it will broadcast out the voltage of the battery. And I'm just got it sending it in millivolts. And you can see when I don't know if I can get both at the same time. I'll click the button. Oh, it failed. Try again. Oh, there it goes. It worked that time. So when I click it, you can see that there was an error here, and it tries 15 times, and it couldn't connect to it. But then it could the next time. So. Anyways, when you send and receive, it shows the success or failure. And this is all coming from this Arduino development board, and it's just plugged in here into COM5 right now. I unplugged the cube from the battery pack here and plugged it into the USB port here, just so I could show the serial output that it's doing right now. So it shows up on a COM7. You can see it just shows whenever it's sending the battery voltage, and then whether or not somebody acknowledged that they received the battery voltage. And so that's what this guy is doing right here. Whenever he sees the battery voltage, he acknowledges it. But every now and then the cube isn't able to send it to anybody, and this error happens. And I'm still going to debug why that happens so frequently, because it does happen quite a bit. It might just be the way that I've got this coded. I'm not using an interrupt for the button. I'm just checking the button state. And so when I do that, I'm blocking for, I don't know, maybe a few milliseconds. And so this thing isn't able to, or the microcontroller isn't able to see if any data was received here and process it, because it's checking this button state using a digital read. I'm not sure, that might be blocking it and causing this problem. But anyways, whenever it sends and this shows what it received, if I go and I click the button down here and to advance to the next color thing, it shows that it sent the number 1 and it was successfully received. This guy up here says they received it. And it just keeps on plugging away, showing the voltage that it's sending. If I go and I advance it to going to sleep, that's sending a number 3. You can see that it received the number 3, and then it went into the sleep cycle, and then it quit showing. We aren't getting any sending of the voltage anymore because it's asleep. So that is the wireless communication so far. And one thing I have when this thing falls asleep, I've just started working on making it do that, and I think I need to halt some USB communication, because when this thing wakes up, so if I click this here to make it come back to life, it's not a, so I start receiving the voltage here from the cube, but the cube isn't acting right. It starts acting real weird, and the communication with the serial port hasn't been reestablished. And if I go and I click the connect and reconnect here, it isn't able to open up the COM7 port anymore, and the cube is going crazy now. So there's something to do. If I don't have it plugged into the USB, when I do this, it works just fine. But when the serial port communication is enabled and I make it go to sleep and then I wake it back up again, it doesn't work. But I know that there's a lot of USB stuff that you can turn off and re-enable and stuff when you're coming out of sleep, and I bet you I gotta look into that. And that might help save some of the power draw when it's asleep, because it's still consuming 20 milliamps when it's asleep. So let's see. Let me. I'll hit the reset button on it. See if that fixes it. Oh, it beeped. Okay, so it seems to be alive again. So I wanted to show another issue, another little trick. In my program, I wanted to read the brightness level with a light-dependent resistor, and I've got that little light-dependent resistor underneath of the radio, right underneath there. I showed that in my circuitry, my little circuit diagram here. I got my light sensor, and I was going to read the voltage, the analog on this analog input, which is hooked up to the RTS connector that's on the prototyping area of the cube. And looking on the data sheet for RTS, here it is right here, it says it's digital pin number 6 or analog pin number 8 for the Arduino style pins. And I tried analog 8 and I wasn't able to get it, any kind of number from this voltage divider. And it turns out it's analog number 7. So if you use the RTS pin, watch out for that. You need to use analog number 7. I just tried all of them and ended up finding that it was analog number 7 was the one. And let's see, another thing is every 2 seconds when it sends the battery voltage, you'll see that the lights on the cube flash, everything turns off. And that has to do with the library that I'm using. So let me show you that. So in my my little loop here for my program, once every 2 seconds, I read the brightness from the light-dependent resistor, and I just read that so I can adjust the brightness of the LEDs, and so at night, so it's not overpowering. And then I broadcast the battery voltage. Well, in the broadcast the battery voltage routine, what I'm doing is I read the battery voltage, which we'll talk about later, and then I do this cube.suspend. And this is the new feature of the library that Angus from Freetronics added for me. Thanks again, Angus. He made it so you can suspend the cube, make it stop doing all the SPI communication that it's doing, make it stop doing SPI calls on the SPI pins of the microcontroller, so that you can use the SPI bus for your other devices. And that's this radio is a SPI device. So I call the suspend, and when I do that, now the little lights turn off. And if I do this real quickly, it's not a big deal, but the problem is the radio library. I'm using this Smurf library here, and I'm sending the battery voltage that I read. And within the library here, you can see that here's that send command. They've got a call to power up TX. This function, this power up TX function right here, it's got a delay of 50 milliseconds in it. So that's a big part of why this thing is flashing. The cube is suspended for at least 50 milliseconds just from that, and then after it powers up the transmitter, it writes to the radio a little bit more, switches a pin high and low, and also it has a delay microseconds in here, 15 microseconds. So this right here is blocking, and it's so it's just going to sit here for a little while when the send is run, and then I've got a loop here to wait to see if we were successful sending out this data, or if we encountered the error that was shown right here earlier. So this thing just loops and loops and loops, and I got a delay of a millisecond here between checking the status of the radio. And so this is a delay. And then when finally all this radio communication is done, you can go ahead and resume the cube communication, and then it just starts setting the colors on the cube LEDs again. So that's why this is flashing. I've got some blocking code in here, and I'm going to have to change the library a little bit to have some asynchronous capability where I can like start a send and then query the status of the send, and do it differently than I'm doing it here. So that should be pretty straightforward. All right, the other thing was reading the battery voltage. I wanted to show that because that was a little bit tricky. So I learned about how to read the battery voltage from a few different websites. This is a really good one. There's a secret Arduino voltmeter is what they call it. It's just a way of measuring the voltage that's being applied to the microcontroller. And the technique that you use is really, really cool once I understood it. It's real simple, but it took me a while to get it. What they've got here in the data sheet for the microcontroller is the formula for what is the reading that you get when you do an analog read. What's the formula that it uses? How does the analog to digital converter that's built into the microcontroller actually work? And what it does is it says that the ADC reading that you read, it can be 0 to 1023. It's a 10-bit reading, so you can get 0 to 1023 whenever you do your analog read. And the number that you're going to get is going to be whatever your input voltage is times 1023 divided by whatever your reference voltage is. And on the Arduino and on this this cube here, the reference voltage is hooked up to. You can change what the reference voltage is, but they have the ability to use this analog VCC pin to be your reference voltage, and you can see that's just hooked up right to the main VCC. So whatever the input voltage is coming into the microcontroller is your analog reference voltage. That's the normal way that Arduinos are set up, and how this is set up as well. So this voltage will be whatever your battery voltage is. That'll be your reference voltage. This analog VCC, the normal VCC, that's just your battery voltage. Or in the case of what's happening here right now, since I have the battery unplugged, it's the voltage that is on the other side of my battery charger circuit. So the battery charger circuit here is connected into the VCC. I don't have the battery plugged in, so it's just whatever's coming off of this pin. It just happens to be 4.2 volts, which is the highest voltage that you would see on a LiPoly battery like this. So right now the VCC that's going into this is 4.2 volts. So we don't know it's 4.2 volts though. We want to calculate it. So using this formula here, you can. And this is all explained on this website, but this is written words and this is a video, so maybe the video is better. So here's the formula here. The ADC reading is equal to Vn times 1023 over your reference voltage. This is the voltage that we don't know what it is. This is going to be our battery voltage. We don't know what this is yet, but we want to figure it out. Well, you can just swap these two so that your your battery voltage, your Vref, is equal to this, Vn times 1023 divided by whatever your A to C reading is. And then what you want to do now is if you can supply a known voltage as your input and then read whatever the analog to digital converter value is, you could figure out what your reference voltage is, what your battery voltage is. And what the Atmel people did is they put in a known voltage that you can use into the microcontroller. So this area here, this A to C register description, down in here, what they do is they show this register, this 80 mux register, that allows you to select what particular pin you want to read your voltage on. And so like in Arduino terms, you like say analog 0 or analog 1 or analog 2, where those are just different pins that are on your microcontroller. So you can see how it says like here, pin number 27 is ADC 10, and that was supposed to be analog 8 according to this schematic, but actually I found out it was analog number 7. Then there's ADC 9, and here's ADC 8, and those correspond to this table down here where you can say I'd like to have ADC, here's ADC 8, ADC 9, ADC 10. So this is how you tell the analog to digital converter, I would like you to read the voltage that's on, pin number whatever, pin number 23 on the microcontroller. And what happens with the way that you do that is you have to set some bits in this register. And this is what the Arduino library does behind the scenes for you. But it turns out that the library, it doesn't have the ability to set the bits for one of these inputs that we want to pick. So you can see it shows the bits that you have to set if you want to read the ADC 0. And one of these that they give you this is the key one. They actually give you a known voltage. Inside the microcontroller, there's this 1.1 volt band gap voltage. And if you set the bits to be that, it's going to read this voltage. And you can now do this calculation because you know that you should be getting a 1.1 volt input. If you can do a reading on that and get whatever the number is, so the ADC reading. So when I do it on this particular microcontroller here, I get 269, and I can just fill in those two values, and bam, I can calculate out that my battery voltage, or the voltage that this thing is seeing at least right now, is 4.18 volts. So that's why they have that band gap in there, or that's one of the reasons at least, is you can figure out what your incoming voltage is by rearranging the formula that it uses when it does an analog to digital conversion. So, so my challenge was, how do I make it read this band gap voltage, knowing that I can't just say with the Arduino libraries, do an analog read on band gap voltage. I can do analog read on like ADC 0, because that happens to be one of the known numbers like A0 or A1, A2. Like I said, this pin here, ADC 10, that's actually A7. So I can do analog read A7, and I will read this particular pin. But I can't do analog read on anything to get that band gap voltage. It's just not in the libraries. So I had to manually go and set the bits in the register in order to make it read this thing. And so these bits here, it says it's mux 5.0. And if you go look in this here, it says this is the multiplexer selection register, and here's mux 0, 1, 2, 3, and 4. There's no 5 here. It doesn't list a 5 here. Well, I didn't notice this So when I was putting the zeros and ones into this register, I was just assuming that, here's the multiplexer selector register, and here's the bits, and I was just throwing in the bit for the band gap. So I was putting these in, and then this last one here, which is supposed to be the fifth one, mux number 5, I was putting it into that 80 mux register, and that was incorrect. Oops, I went too far. It was incorrect because that particular bit was a different bit, this analog digital left just bit here. So that's what really threw me off. They have a little number 1 here, and this note, if you click on it, it actually says the 80 mux bit is part of a different register. And so they tried to help me out. I just didn't notice it. So anyways, this particular bit, you have to go past all the input selection information. There's this different register here, this status register. You go past it, and there's the data registers. This is where the result of your analog reading is stored. And you go past it, and then finally you get to this other status register, control status register, and here's that little mux number 5 sitting there. That's where it's at. So in my code, my little read battery voltage function. So down here, you can see I set the bits, that mux 1 and then 2 and then 3 and 4, but I needed to make the 5th bit a 0. Again, I'm trying to select that 1.1 volt band gap voltage. I needed to make it a 0, and I needed to do that in a different register than that 80 mux register. So that took me a long time to figure out, but I finally did it, and now it's working, and I'm using the formula, the 1.1 times 1023 divided by whatever my reading is that I get, and that gives me my voltage, and then I convert it to millivolts by multiplying it by 1,000, and that just makes it so I don't have to deal with a floating point number. So that was the last little trick I wanted to show.